So here's example 3 for the 2.5 notes. So we're going to divide our polynomial by using synthetic division. Now we can only use it because in this case our polynomial, our divisor, is in the form of x minus k. So in this case we need to figure out what our k value is so we can divide it. Now in order to find your k value, you actually have to do the opposite of what you see. Because remember, the form is as x minus k. So this is really saying like x minus a -3. So k equals -3. So I'm going to put -3 here. I'm going to use a half box. Now what we need to do is use all the coefficients from our polynomial. So we start at x cubed. So I'm going to say our x cubed coefficient, our x squared coefficient, our x to the first power coefficient, and x to the 0. Remember, x to the 0 just means our constant. Now, if we did not have one of these terms, we would have to use 0 as our placeholder. So our coefficient for x cubed is 2, coefficient for x squared is 1, for x to the first is -8, and then for x to the 0 power it's 5. So what I did here was I took my 2 and I brought it down below the line. Now what I need to do is I need to take my k value and multiply it by the 2. So I do -3 times 2 to give me -6. Now I take the 1 and add it to -6, I get -5. I do the process again. I do -3 times -5. That gives me a +15. And I'm going to add my -8 to the +15. So this should give me 7. And once again, I'm going to do -3 times 7, and that should give me -21. And I add 5 to my -21. That should give me -16. Now this right here is what we call your remainder. So remember, we put the remainder over the divisor. So really our divisor is the polynomial. So we'll put it over there. Now because you're dividing by a polynomial, when we write our answer, you're going to write it so that you have one less exponent. So that means your exponent should go 1 less. Since we started at x cubed and we have to go 1 less, we should start now at x squared. Now I take the 2 because that's going to be the coefficient of my x squared. So that means -5, that's going to be the coefficient of my x. And then 7 is going to be the constant term. Now I add my remainder, so I do plus a -16. And I put it over my divisor. The entire polynomial, that's what you want to put it over. So it should be x plus 3. So your final answer, because you are writing your answer as a polynomial, should be 2x squared minus 5x plus 7 plus -16 over x plus 3. Make sure if I'm going too fast, you pause the video so you can write all of this down. Okay, example 4. Now this is using the factor theorem. So they're saying a polynomial f of x has a factor x minus k if and only if the remainder is 0. So if you're using synthetic division, at the very end you should get a remainder of 0 as your answer. So we're going to factor 3x cubed minus 4x squared minus 28x minus 16, given that x plus 2 is a factor. So here, remember, we have to do the opposite of what we see, so our k value in this case is -2. So I'm going to use synthetic division to find my next polynomial. So I have -2. I'm going to divide all of that with the coefficients. So remember, we have now, since we're starting with x cubed in our polynomial, we have our x cubed, our x squared, our x to the first, and x to the 0 power. That's our constant. So I write basically the coefficients of each term. So for the x term, our coefficient is 3. We have -4 as our coefficient for x squared, -28 as the coefficient for x to the first power, and then -16. Now, I bring the 3 down first, so you always need to bring that down first. And I take my k value and multiply it. So I do -2 times 3. That should give me -6. So I add the numbers together. So I do -4 times -6. That gives me -10. I do negative 2 times negative 10 to give me a positive 20. I add these terms, so negative 28 plus 20, to give me negative 8. And then here, when I have negative 2 times negative 8, I should get a positive 16. And I add that, and I get 0. And if you notice, we get a remainder of 0. So we did it correctly. There we go. So that's remainder. Now, just like we did last time, we do have to use our coefficients here to write our polynomial. Now remember, since we started with an x cubed, we have to go 1 degree less. So that means we start with x squared. So we're going to take the 3, that's going to be the coefficient of my first term, so I have 3x squared, minus, now we go to the next term, which is minus 10x, minus 8. Now here, what we need to do is we need to factor this more, because we need to factor basically this entire polynomial, given that x plus 2 is a factor. So I do need to write that out, so the x plus 2, and multiply it by my 3x squared minus 10x minus 8. Because all I'm doing here is using the synthetic division to factor the polynomial. So now what I need to do is I'm going to factor the 3x squared minus 10x minus 8, and I'm going to factor that just a tiny bit more. So I bring down my x plus 2, because that is already a factor. And then I create 2 more sets of parentheses here. Now, when you factor this, right, just like we've done with quadratics, you want to find all the numbers that multiply to 3 and all the numbers that multiply to 8. So we have 1 and 8, got 2 and 4. So we definitely know we're going to have an x and a 3x. And then here, you're just basically using either 1 and 8 and 2 and 4 so that you can add up to a negative 10x. So let's go ahead, let's try a 2 and a 4. So I'll go ahead and put 4 here and then a 2. And remember, when we did this, we did our inner, so we multiplied that to give us 12x. So that's a 12 there. And then x times 2 to give us 2x. And if we did any assortment with this, we should get negative 10x, which we can, as long as our 4 is negative, so that means the 12x had to be negative. And then we have 3x plus 2. So that means our final factorization, so I'm going to rewrite this. So our final factorization is x plus 2. And then we have x minus 4. And then times 3x plus 2. And so this would be our final answer here. So that's how you use synthetic division to factor a polynomial. Okay, last problem we have. So in this one, we're going to use synthetic division to find 1, 0 of our polynomial when we already know that x equals 3, which that is a 0, okay? So we can find the other zeros of the function. So we are going to use synthetic division basically to find the solutions to this problem. So since they already gave us k, so x equals 3, that's already our k value. So we put 3, and remember, I want the coefficients of my entire polynomial. So that means the coefficients of our x cubed, x squared, our x to the first, and our constant terms. So 1 is the coefficient. We have negative 2, negative 23, and then 60. Now, because we're finding zeros, we want to make sure we get actually a remainder of 0 so we can factor our, basically our polynomial here. So we bring the 1 down. So we bring the 1 down. And we do 3 times 1. That gives us 3. And so we add negative 2 and 3. So that gives us 1 again. We do 3 times 1. Well, that gives us 3. We add negative 23 and 3. That should give us negative 20. And then we multiply 3 times 20 to give us negative 60. and we add that, and we should get 0. Because we get a remainder of 0, we know we did this correctly, so that's our remainder. So now what we need to do is rewrite our polynomial. Remember, because we started with an x cubed, we do have to go 1 degree less. So that means we start with an x squared. 1 is going to be our coefficient of x squared, so you can either write 1x squared or just x squared. Our next one's going to be a positive x, and then we have minus 20. Now from here, we're going to set our function or our polynomial equal to 0 because we want to factor this just a little bit more so we can find all the solutions of the function. So we're going to go ahead and factor. So this one's a little bit easier to factor because basically all you're doing are finding two numbers that multiply to 20 and add up to a 1. Well, you guys should know that should be 4 and 5. And because we're adding up to a positive x, or a positive 1, we want a plus 5 and a minus 4. So now we set each of our factors equal to 0. So we do x minus 4 equals 0. And we do x plus 5 equals 0. We solve for x, so we get x equals 4 and x equals 5. Or sorry, x equals negative 5. So our other zeros, meaning the other solutions to the polynomial, are x equals 4 and x equals negative 5. And notice that the 3 that we have here, that is also a 0 or a solution to the original polynomial right here. Okay, remember, if you have any questions, there are the filled-in notes on Google Classroom. You can come in before or after school or email me. So make sure you get all of this down. I'm going to go ahead and scoot down just a little bit. If you need to pause it so you can write all this down, that might be a good idea. Okay, so the homework's on Google Classroom. It is the textbook problem, so make sure you look at that. And the homework will be due tomorrow.